Hi, welcome to another video session on linear momentum and collisions. In this video, we're going to look at question 3 from the University of Zambia, PHY 1010 tutorial sheet. So question 1 and question 2 have already been worked out. I'll attach the link to that video in the description below. So let's quickly go to the question we're supposed to work out today. So this is an interesting question. They're talking about two billiard balls, one initially at rest and the other one approaching it at 6 meters per second. So then what happens is collision of course takes place, and they're saying this is elastic collision, which of course just implies that kinetic energy is conserved as well. And then once collision takes place, the initially moving ball moves at this angle from the initial direction, 25 degrees. And then what they want us to find is the final velocities of both balls. And apart from that, the direction of the ball which was initially at rest. So let's see what we're going to find. So it's a little bit tricky, but it can be done. So let's see. So the first step is to just reconstruct what the question is trying to ask of us. So we have one ball, let's call it B, at rest. And then you have another ball approaching it. Let's call it A. The balls are of equal mass. So these two balls are identical. So the mass is just going to use M for both. Okay, so this is moving in this direction towards ball B at 6 meters per second. And then after collision, ball A goes in that direction. And then ball B, let's say it goes in this direction. So the question specifies that the angle here, let's call it theta, is equals to 25 degrees. But we want to find this angle here, let's call it alpha. So apart from that, we also want to find the velocity of B final, and then also the velocity of A final. So these are the three terms we have to find: the velocity A final, the angle B makes, and then also the final velocity of B. Okay, now how do we do this? So to work it out, so the first thing that we have to do is to conserve momentum. But momentum is a vector, so we have to conserve the respective components. So in the x-axis, what we have is we have the momentum of A plus the momentum of B initially equal to the momentum of A plus the momentum of B final. But of course, in the respective, just the respective components. But B is initially at rest, implying that its momentum is 0 initially. And then A is moving completely in the x-axis, meaning that its y component of momentum is 0. The 6 meters given is the velocity in the x, which makes it the x component of our velocity, which makes it all the x component. So in the x, we're going to have m times the velocity of A initially, which is the whole 6. So here I'm not using cos because cos the angle there is going to be 0. So cos 0 is just going to give me 1. So it's just going to leave this. Then I'm going to have m VA final now, but cos the angle is given to us. We used a theta there. So I'm going to say cos theta plus m VB final cos alpha. Okay, now what happens? So the masses cancel out, they're common throughout. And then apart from that, we make our substitution. This is a 6. And then this is VA final. And then this is cos 25, or theta is 25, plus VB final cos alpha. So we're just going to make this term alone on the left-hand side, on the right-hand side. So we'll move this to the left-hand side. This becomes 6 minus VA final cos 25 is equals to VB final cos alpha. So this becomes our equation 1. So now when you look at this, we have the first term, this term, VA final, we have VB final, and then we have alpha. So we have 3 terms that we do not know, but we're trying to find. So since we have an equation with 3 unknowns, we need 2 more to work them out as a system of equations. So let's quickly move to the y-axis. So in the y-axis, we have to notice that again, mass A, or the ball A, is moving in the x, meaning it has no initial component in the y, so it becomes 0, its momentum in the y. And then mass B was also at rest, so it has no momentum in the y initially. So the left-hand side from the conservation of momentum is 0. but the right hand side will have values. So we're going to have m, the mass of A, multiplying the final velocity of A. But to get its y component, we'll say sine theta, plus the mass of B, the final velocity of B, sine alpha. But when you look at this, alpha is an angle in the fourth quadrant. So if I made an axis here, alpha is an angle in the fourth quadrant. So when we evaluate sine in the fourth quadrant, the answer we get is going to be negative, implying that the summation here becomes a negative, a difference. Okay, so after doing that, the masses are going to be common, they're going to cancel out. So what remains is going to be, and then I move this to the other side, or I move this to the other side. What remains is going to be VA final sine alpha, sine theta I mean, equal to VB final sine alpha. Then I'm just going to substitute here. So now we have VA final sine 25 is equals to VB final sine alpha. This becomes our second equation. So again, I said we needed 3 equations. We'll come up with the second one. Let's see if we can come up with the third. So the type of collision that occurs is elastic. So what that means is kinetic energy is conserved. So if we looked at this, it means that the initial kinetic energy before collision must be equal to the final kinetic energy after collision. So it's the kinetic energy of A plus the kinetic energy of B before collision, which must be equal to the kinetic energy of A plus the kinetic energy of B after collision. But B was initially at rest, implying that its kinetic energy was 0 before collision. So we move on to what remains. So this becomes half mVA initially squared is equals to half mVA final squared plus half mVB final squared. The masses and the half go away, they're common, so they're going to cancel. What remains is VAI squared is equals to VA final squared plus VB final squared. So after doing that, this becomes our third equation. So let's just collect our equations and see what we now have. So we had the first equation was 6 minus VA final cos 25, which was equal to VB final cos alpha. This was our first equation. And then our second equation was, we just had a simple one. So this was VA final sine 25 equal to VB final sine alpha. So this was our second, I mean. And then the third equation was the one we just from finding. So this was, so that was, let me just take a look at it again. Yeah, this one, VAI. Okay, all right. So this was VAI squared equal to VAF squared plus VBF squared. So remember, the VAI is just a 6. So VAI is just a 6. So this means that here we can just have 6 squared. Of course, 6 squared, this term just becomes 36. Okay, now let's see. So what we're going to do is, you see, we want to use the 3 equations. So one method that we're going to use is we're going to square this entire lot and square it here, then substitute what we're going to have into the third equation and see how it works. What do I mean? I'm going to square this, the left hand side and the right hand side of each term. So I'm going to square here, and this. Then I'm also going to square here, and I'm going to square here. So after I square them, I'm going to add them. Let's see what happens. So if I square this, so the left hand side becomes, so this is going to be 6. This is going to be 6 times, so it's going to be 6 times 6, which is 36, minus 6 times that, this becomes 6. VA final cos 25 minus, again it multiplies 6 VA final cos 25. So if you look at this, this just makes a minus 12. So it's basically the same thing, but instead of a minus 6, this is just minus 12. Okay, so apart from that, this will multiply itself, so this becomes positive VA final squared cos squared 25. That's the left hand side. The right hand side just becomes VB final squared cos squared alpha. Okay, so that's what I get when I square the first one. How about when we square the second one? So squaring the second one is pretty much straightforward. This becomes VA final squared sine 25 squared, which is equals to VB final squared sine squared alpha. Okay, so now having done this, so let's say this is our, yeah, so we have, let's label them again. So that was 3. This becomes equation 4. This becomes 5. Okay, now I'm going to add equation 5 and equation 4 and 5. So what is going to happen? So if I added, so when you add 4 and 5, so what you should notice is from the left hand side, I can just add them where I can see them. Let me just, we'll get this back. So when you add 4 and 5, what happens is the left hand side, we have this, which becomes 36. Let me use black for this. So the left hand side, we have 36 minus 12 VA final cos 25 plus VA final squared cos 25 plus this term from 5, which is VA final squared sine squared 25. So this is just the left hand side. Okay, now what happens? Now we can simplify the left hand side a bit more. Now notice this term. I can factor out VA final squared from each part. So this is now 36 minus 12 VA final cos 25 plus VA final squared, and then I remain with, this has a square here, so I remain with cos squared 25 plus sine squared 25. So if you recall from the you work with trigonometric identities, this is a 1, implying that the left hand side now remains as 36 minus 12 VA final cos 25 plus VA final squared. So this is the left hand side. Now let's look at the right hand side. So for the right hand side, we're just going to add this term plus this term. So that's VB final squared cos alpha sine alpha. Okay, so from the right hand side, we have VB final squared cos alpha squared plus VB final squared sine alpha that's squared as well. So again, if we look at this, we can factor out VB final. So this becomes VB final squared, open bracket. This is again cos alpha squared plus sine alpha squared. So this just simplifies to give VB final squared, since this again is a 1. So that's the left, this is the right hand side, that was the left hand. So I'm just going to equate them again. So that's 36. Let me use a different color for this. Okay, so now we're going towards the end. So that's 36 minus 12 VA final cos 25. This is plus VA final squared is equals to VB final squared. Okay, so we've reached the stage. Let's call this our equation 6. Now we're going to bring equation 3, sorry. So if you remember, equation 3 was 36. That was 36, and then this was equal to VA final squared plus VB final squared. So this is the equation we got from conserving kinetic energy, and this was our equation 3. So now I'm going to use equation 6 and equation 3 to see what we come up with. So if you notice this, here we have VA final as well there, but this is squared. So now what we're going to do is we're just going to make a simple substitution. Okay, yes, we're just going to make a simple substitution from equation 3. We're going to make one term the subject of the formula, and then substitute it into equation 6. Okay, yeah, so basically that is what we are going to do from there. All right, now how do we do this? So in this case, so here we have we can eliminate any of this term. We can say VA final squared is equals to 36 minus VB final squared. Right. So then now we're going to substitute this in there. So where we have VA, we're going to substitute that. Okay. Now for simplicity, yeah, this works as well. This works as well. So we then substitute this into that. I think the easier one would have been to substitute for VB final since it's on its own. Let me just do that. So VB final is on its own. So I'm going to make VB final the subject of the formula. VB final squared is equals to 36 minus VA final squared. So now I'm going to substitute this into equation 6. This becomes 36 minus 12 VA final cos 25 plus VA final squared is equals to 36. I'm substituting VB final by this side. So 36 minus VA final squared. Okay. All right. Now, what do we remain with if we did this? So we're going to have 36 minus. So grouping the like terms, this term comes this side. It becomes positive. So these two terms are going to add up. We're going to have 2 VA final. Yeah, we're going to have 2 VA final. Okay, so this term becomes a 36. So this 36 comes this side, so it becomes 36 minus 12 VA final cos 25 plus VA final squared plus VA final squared is equals to 0. So this term becomes 0 and this term adds up. So now we have minus 12 VA final cos 25 plus 2 VA final squared is equals to 0. So notice that we can divide through by VA final here. VA final can cancel out, can divide through ones. Then you also divide through by 2 here. Okay, so if we did that, would remain with a minus 6 cos 25 minus 6 cos 25 is equals to, here we've divided through by 2 and VA as well. What is equals to? This is plus, so this becomes VA final is equals to 0. So from here, we notice that when this term goes the other side, VA final becomes just 6 cos 25. So we're concluding that VA final is equals to 6 cos 25. And then if we evaluate this, 6 cos 25, 6 cos 25, we get 5.44. So we're getting 5.44 meters per second as the final velocity for VA. Okay, now using this, having obtained VA, we can get our equation 3 again. So equation 3 was for the one we got from kinetic energy, which was this one here. So we can substitute where there's VA, we can substitute here, and this will give us what VB is. Okay, so how do we do that? So if we substituted in that equation, so that equation was 36 is equals to VA final squared plus VB final squared. So if we substitute our expression for VA, which is 5.44, so that becomes 36 is equals to 5.44 squared plus VB final squared. So this term goes to the other side. We now have 36 minus 5.44 squared is equals to VB final squared. So what we get as our VB final. So if we did that, we can square this. And then after squaring it, we need to subtract it from 36. We get 6.42, 43 I mean. So now we need to square root this. We get 2.54. We get VB is equals to 2.54 meters per second. Okay, so let's just see where we are. So yeah, so our answers so far are okay. So our answers so far are okay. We have 5.44 and 2.33. So here we put 2.554. Just okay. All right, so the last step would be to get the angle. So to get the angle now, we're going to pick any one of our equations. We can pick any one of our equations. We can use the one we got from, which was our equation 2. So let's just quickly look at equation 2. So equation 2, we had this one here. VA sine 25 is equals to VB sine alpha. So I want to find alpha. So we had VA sine 25 is equals to VB sine alpha. So this is VA final, which is we found VA final somewhere here, which was 5.44. So when we substitute here, we have 5.44 sine 25 is equals to, we just found that our VB is 2.54 sine alpha. So divide both sides. We now have sine alpha is equals to 5.44 sine 25 over 2.54. Okay, so let's see what we get. So we have 5.44 sine 25. We get that divided by 2.54. We get 0. Over that. Okay, now we have 0.905. So that sine alpha is equals to 0.905. Okay, so now we get sine inverse. So alpha is equals to sine inverse of 0.905. And we should be able to see that this gives us 65 degrees. Okay. Now, so this was a very, very long long calculation, but it can be done in a shorter way. But hopefully, I hope this this will be able to help you understand how to work it out. So try it out on your own again after going to the video and see if it is helpful. So if you found this video helpful, just leave a like. You can subscribe to the channel just so that you don't miss any future videos that I upload. All right, thank you very much. If there are any comments, just leave them in the description, or you can forward them to my email in the description as well. All right, thank you very much. Next time.